接下来呢，我们的嘉宾呢会用他的电脑啊。接下来的是 Greg， 来自加拿大，他现在呢是一个 iOS 的一个自由职业者啊，开发的自由职业者。OK， 那 welcome Greg.
All right, good morning. I'm excited to be here in Beijing in China for the first time and talk to you about Swift style, whatever that means. But I hope by the end of the talk, everybody gets a better idea of what I'm talking about. So I've been writing and I've been reading a lot of Swift since it was released at the beginning in June of 2014. And so I want to share some general ideas on what it's like working in Swift, how we might write more effective and elegant code, considering that we're lucky enough to be working in such a modern language that was designed so recently. So what do we mean when we talk about style? I guess some of it is sort of like a style guide. Maybe you have one in your own company, something like use two spaces, use tabs, put the opening brace on the new line, don't use trailing closures, always use trailing closures, and so on. So some people say that that stuff doesn't matter and that the code will all compile down to the same thing at the end, which is kind of true, right? We have source code, and then you have your lexer, your parser, your compiler, and then way down at the bottom there, we'll get our machine code. So that's kind of true. The compiler doesn't really care what your code looks like as long as the syntax is correct. And if you write something that looks like this, and you use everybody's favorite punctuation, the semicolon, then you can get this to run in Swift. But we don't see this very often in Swift, right? Because who wants to look at code like this? This isn't JavaScript. We don't care that everything is very, very small. Because what we want as programmers is we want readable, well-formatted code for ourselves, right? But is that it? Is that what Swift style is? It's just a matter of formatting and looking nice and doing good indentation? Or is there more than that? So that's sort of the bigger question that I want to talk about. This is one of my favorite computer science textbooks called The Structure and Interpretation of Computer Programs. And the authors talk about what computer languages and what programming are, what it really means. And the important part for me is that they say that computer languages aren't just a way to get the computer to do what you want. So it's not just a list of instructions. Do this, and then do that, and then do that, and then the computer just runs through them in series. But instead, think of a computer language as a way for you, or us, the programmers, to express some kind of idea. So of course, you write the code, but as you're writing the code, you have some kind of idea in mind, right? Maybe you use comments or something like that, and you have an idea. This line does this line does this line does that. And so there's a few levels. There's the code that the computer reads, and then there's going to be the code that you have to read, maybe with comments, and then there's like a big, big picture on top of it of what does this code actually do. So that's everybody's favorite bubble sort in assembly language. So those are the multiple levels, right? From code to that the computer reads, code that we read, and then what's the big idea here? So this is a famous quote from the book. I think it's famous. Programs must be written for people to read and only incidentally for machines to execute. So the idea is put people first. Make the code so that we can understand it. I think it's a common piece of advice. I hear it a lot. Some people call it literate programming, right? Computers will always remember, with no spaces and semicolons, computers will have no problem understanding your code. But it's the people reading the code that you have to worry about. There's another famous book called Refactoring, and there's another good quote there. Good programmers write code that humans can understand. So that's what I want you to keep in mind, and I want everyone to keep in mind for the rest of this talk, is when I write Swift, how can I write it not just to tell the computer what to do, but to express some kind of idea? And also make it so that when I come back to my code next week or next month or next year, I can still understand it, and it doesn't look like this. So is this something we can do in Swift? Is Swift a language for literate programming and ease of understanding and just style in general? So I think so, and I hope, well, if you're all at this conference, I hope that you'll agree as well as the talk goes on. Let me jump ahead a little bit and talk about sort of what one of the conclusions is. And I think something that Swift style gives us a lot is concise code, right? No one wants to read 10 lines of code or 100 lines of code where you can just do the same kind of work in a single line. You don't want to reinvent the wheel. You don't want to make your own string and make your own array and then have to test it and have all of that extra code. Instead, you just want to use the built-in stuff if it works just fine. So I think that was one of the immediate things, concise code, that a lot of us noticed when we went from Objective-C to Swift. Can I just ask quickly, how many people started doing iOS or Mac development in Objective-C? Lots of people, almost over half, so okay. So here's a little bit of Objective-C. So some people say that, or some language designers say that it's the special characters and it's the symbols that make languages look complex. So a lot of people don't like Perl for that reason. There's a lot of reasons not to like Perl, but Perl has dollar signs and at signs and percent signs and semicolons and all of that. And I think people said the same thing about Objective-C. They didn't like the square brackets and they didn't like the at signs. I don't mind it as much, but some people really didn't like the look of the language. So we've got square brackets, we have an at sign in front of the quote, we have name parameters, and then they have a colon, we've got a block syntax in there, and then of course we have a semicolon at the end. So it's not bad. A lot of us wrote this kind of code for many, many years, and we're still here and we survived. So how is this going to look in Swift? A little bit better. We got rid of the square brackets, and we got rid of the at sign in front of the quotes. When you want to start a block, you don't have to do the caret character anymore. You just do an opening brace, and you can start a closure expression. That's not bad. What else can we do? In Swift, the self is usually implicit, unless you're inside a closure, so we can get rid of the self. That part is optional. And the compiler will know that we're calling this on self, so we should be OK. And then we can look at trailing closure syntax. Because the closure is the last parameter for this method call, we can get rid of the final parameter and put the braces for the closure outside of the parentheses. So if you've used the collection type methods like map and filter that we already saw, then you know how convenient this syntax can be. So here it is side by side. What have we gained? We went from 83 characters to 61 characters, so it's about a 25% reduction if you're counting. And as Chris said, deleting code is always the most fun part, I think, of programming. But again, how important is this? I think the Swift version here is definitely more readable, and it has more style. And I found that Swift is often shorter than Objective-C. So I think that's part of what Swift style is. But again, is that everything? Is that all it is? We just want shorter code, and that's everything? So I think concise code is an important improvement and a definite feature of Swift style. But again, there's more than just counting characters. I think what it really is finding out what the nature of Swift code is and then following along with that. So if Swift is taking you in this direction, then have your code also go in that direction. And that's kind of what I want to think about in Swift style. If Swift is sort of pushing you to use a certain set of features or not use a certain set of features, then try and go along with what Swift is doing rather than, like the fish, going upstream and going against what the direction that the water is going. All right, so what are some of the big pictures of Swift that we can look at in terms of writing good code in a Swift style? I have sort of a random grab bag collection of things in Swift that I want to talk about, but I've broken them down, as you do in talks, into 3 categories: value types, protocols, and safety. So let's talk about these. First up for value types is immutability, which we heard a little bit about in Chris's demo with structs, and I'm sure we'll hear more about when we hear about functional programming. So in the Objective-C world, we had these set of classes to hold our data, right? We had NSArray, NSData, NSDictionary, and so on. And these were immutable types. So we're already used to that, having the data that you can't change after you've created it. And then to go along with that, we had a second set of mutable data types. And that was the way that Objective-C kept us straight. They said, we're going to change the name of the type. If you have an NS string, then you can't change it later. And if you have an NS mutable string, then you can change it later. So it's different types. Whereas in the Swift style, any named type you can set as constant or variable. So you declare it with let, it becomes a constant and immutable. You declare it with var, and it becomes variable and mutable, if I said that right. And again, you saw in Chris's demo with the structs how changing it from let to var, the compiler will give you some hints on if you try to change it and it doesn't like it. What kind of examples is useful? Maybe a functional programming example is a good one. If you have some function, and it has some inputs, and it gives you some outputs. So in a pure function, it only uses those inputs, doesn't look at anything else, and it just gives you the output. And it should give you the same output for any input. But of course, when we're programming in large systems such as apps, there's always this looming thing of state that's around the system, right? You have your window, you have your screen, you have other things going on in the background, and that's always a concern that you have to think about is with state. But again, we'll hear more about that in Hank's talk on functional programming, which I'm very much looking forward to, so I won't talk any more about that. And then also helping out if you use a lot of immutability is concurrency, right? If you have one thread that's doing something, you have another thread that's doing something else, and you pass some data back and forth, and if it's mutable data, then you have to worry about synchronization and locking and all of those not so nice things that we have to look at as programmers sometimes. So immutability, keeping immutable data will also help a lot with concurrency. And why I think this is part of Swift style is that the compiler will help you out, right? If you declare a variable with var and you never change it, then the compiler will give you a little hint, a warning, and say, hey, you never changed it, you should think about making it immutable. And then it'll give you a little fix-it, I think, and change it to let instead. All right, so that's immutability. I think it's something that we're already used to from Cocoa, again, because we had the NS string versus NS mutable string, and we had that in the Objective-C days. And I think it's still a good idea in Swift, and Swift makes it a little bit easier with just the keywords, right? Let and var. So it's something that's right inside the language, so I think it is something that Swift is really pushing. All right, next up with value types, enumerations. Again, you saw a great demo from Chris, so I don't need to get into very many more details about structs. But since he already covered structs, I'll talk about the other value type that's like a little brother to structs, which is enumerations. If you look in the Swift standard library, or if you remember from Objective-C, everything pretty much was a class. But if you look in the Swift standard library, it's flipped around. Almost everything is a struct. A couple of classes, and a couple of enumerations. So the balance is definitely towards value types. So let's look at enumerations and see how we can use those and how they sort of fit into a Swifty style. All right, so let's say we're building an enumeration. I've got this code here in Objective-C. If you're writing C, you can just say enum and give the definition. But because we're in Objective-C, it has to be a little more complex. There's a type def, there's this special character, ns_enum. You give the backing type, you give the name, and then there's a lot of repetition, right? Because for every case, you repeat the name. You say transport mode airplane, transport mode boat, transport mode truck, and so on and so on. But this is the way that we did it in Objective-C. So if we switch it over to Swift, what's it going to look like? A little bit cleaner. It's just a single keyword. You give the name of the type, and then we have our three cases, right? And we don't have to repeat the name. We can just say airplane, boat, and truck. That looks pretty good. I should note, I'm not as brave as Chris to do live coding, so that's why I have the code up here on slides. All right, so now let's say we want this function, and it's a emoji for transport mode. So you pass in an instance of your enumeration, and then it returns you the associated emoji for that particular thing, either like the airplane icon, the boat icon, and so on. So we have our enumeration definition, and then we have this function. It takes an enumeration instance and returns you a string. That looks all right. That's maybe, again, how we would do it in Objective-C. But then another great thing about enumerations is Swift is that they're almost fully featured name types, right? So they can have things like methods. So if we take this function and move it into the enumeration definition, then it becomes a method. I'll just call it emoji representation. It doesn't need to take a parameter anymore. And if you look at the switch statement, we just switch on self. And if it's again, airplane case, we return that. The boat case, we return the other thing, and then for the truck case, return the truck emoji. And then I had that as a method, but then you could say, well, this is really read-only. Why don't I turn it into a property? So I can declare it with var. This is going to be a read-only property, though, no setter. And instead of being a function, it's now going to be a property to return a value like that. And then if we again think back to Objective-C, all the enumerations had to be backed by integers, whereas now in Swift, your enumerations can be backed by characters or strings or floating point types. And so we can use a string raw value, and we can move those 3 emoji directly into the types themselves. So now we just have, I've changed the definition, so it's backed by a string, and I set the individual string to each case. And now, when I instantiate one, I can just ask for the raw value, and I'll get it back. As an extra bonus, if you declare another case here, so I've got a case for rocket ship now, and I give it the emoji, and that's fine. And then later on, if I have a switch and a case, if I forget it, it'll say your switch wasn't exhaustive. I'm sure we've all run into that error. But because I've repeated the same value, I have the same airplane emoji, then again, the compiler will help me out and say it's not unique, and you need to find a rocket emoji, not the airplane emoji. All right, so enumerations. They're really good for a well-defined set of values. And if you watch the WWDC session number 411, Swift in Practice, the gentleman in the presentation does some interesting things where he defines all of the segues in your storyboards using an enumeration, and he also tries things that you have in your asset catalog. All of the images you have in your app, he defines an enumeration for that, so that when you ask for an image, you give it by the enumeration, and then you get full type checking for things like that. So it's an interesting talk to look at if you want to look at how to use even more enumerations in your apps. But enumerations are now a full feature type in Swift, so that means you've got computer properties, we have methods, raw values, and I didn't talk about associated values, but each case can also have its own associated value. So I think as we move towards thinking more about things as value types, structs and enumerations, rather than everything being a class, as we used to do in Objective-C, then aside from structs, think also about enumerations. Again, when you have a set of values that you know is going to be fixed for your app, then enumerations are now a good, really good, powerful type that we have, not just like enumerations were in Objective-C. All right, let's move on to protocols. I'm not going to talk about protocol-oriented programming because, again, we're going to hear about that this afternoon. But I want to talk about how we can use protocols more to make our types feel native in Swift. So here's the sample struct that I've built. It's just called sentence, and it has a single string, just called sentence again. And I have a basic initializer, and that's it. And the ... is, of course, the magic symbol saying there's much more code, and the sentence will do things like maybe check the spelling. It'll be able to analyze the sentence for errors or grammar errors or something like that. So we've wrapped a simple string into a sentence struct. And that's how I'd initialize it. I just say let. I'm using let to be immutable. I've got my type, and I call the initializer with a string, hello world in this case. But when you're building with value types, you want your value types, again, to fit into Swift, and you want them to feel almost like native types. So what does that mean? That means I want to be able to do something like this. If I have 2 sentences, I want to say equals equals, and I want to compare them. Again, if you remember from Objective-C, if you had 2 strings, then the way to compare them was to say is equal to string and the second string. You couldn't do something like equals equals. But I want to do that because I want my type to feel like it's native to Swift. I don't want a method called sentences are equal and I pass it 2 things. I don't want any of that. I want to just use equals equals. There's also comparison. You could do something like ordering by alphabetic order. So one sentence could be greater than or less than another. And I just want to use the less than and greater than types natively. And then, of course, I want to print it out, because a sentence is just a string behind the scenes. So I want to be able to print it out and show something that's reasonable. So how do we do that in Swift? Of course, it's using protocols. So there's a protocol called, no, this is just our struct definition, just to remind you. Now let's have a look. So we've got an extension on our sentence struct. First one is going to be equatable. So there's actually nothing that you have to do in the extension, but all you need to do is define an equals equals function. It takes 2 sentences, and all I'm doing in the implementation is just comparing the string inside. So if the string in the first sentence is the same as the string in the second sentence, this will return true. And then with that, that's all I need to do, and I can do sentence equals equals other sentence, and it just works. Comparable, same kind of thing. I'm going to compare two sentences and see if they're less than or greater than. And same thing, I just go down to the string, and because strings are already comparable, I can just call less than on the string that's inside the struct. And then I can just compare the two strings like that, and I could get sorting and other things like that. And then the third one is to print it out. So right now, the sentence as I have it, let's say I did a print statement like this. What would it look like? It looks something like this. Sentence, sentence, hello there. It's not so nice. We just wanted to say hello there, just the string. So again, there's another protocol to use. In this case, it's custom string convertible. And in the implementation, you just return what is the string that you want this to be. And so once I have that set up, then next time when I try to print out my sentence, then I'll just get hello there without the sentence, all of that wrapper stuff around it. So that, I think, is the essential stuff that you should have, at least equatable and custom string convertible. If you ever have a value type, it's always good to have those, because if it's a value, you should be able to compare them and see if they're the same thing or not. And then depending on what your type is, there might be some extra bonus things. For example, in initializer. If you look at the first example, it's using the initializer. So I say sentence, open parentheses, and I give it a string. But if you look at this second example, because sentences are just strings, why can't I just say, I have this variable, or this constant, it's a sentence, and I just want to give it a string. I don't want to call the initializer. Why can't sentences just be strings? So that's something else to look at. There's the first one. And then here, I'm just passing in a plain old string. That would be nice to do, because again, sentences for us are just strings. All right, next up, I want to put my sentences in dictionaries. I want them to be keys in dictionaries so I can give them values. So by default, I can't do this. But again, I want my types to feel native and like Swift. And then maybe I also want iteration. So since a sentence is made up of words, why can't I have a for loop through the sentence, give me the first word, the second word, the third word, and so on until the end? So let's just have a quick look at some of the code there. So the first one is string literal convertible. This will let you take a string in quotes and just make it into a sentence automatically. There's a little bit more code than this. There's also Unicode things and extended grapheme cluster, which is a few extra lines, but I've just left it out. The implementation here is very simple, though. You just need an initializer that takes a string, and in our case, all we do is set our sentence to whatever they passed in. And then I can just do this. If I have a sentence variable or constant, I just give it a string, and it'll just work. All right, next up is hashable. So this will let me store the sentence in a dictionary. It can be the key to a dictionary, or I could also put it in a set. So again, I'm cheating a little bit. Because strings are already hashable, I'm just going to call through down one level, and I'm going to ask the string to hash itself and just use the same value. And it's the same kind of thing. I can now use my sentences as keys to dictionaries, and I can also add them to a set. And the last one is iteration, which is a little more complicated. But if I conform to sequence type, which is things that like arrays and dictionaries conform to sequence type, then all I need to do here is create some kind of an array. So I'm just going to separate the string. If the string is a sentence, so it has a word and then a space, another word and then a space, maybe you could do commas and periods and other punctuation as well. So once I have that, then I set up a second type, in this case, sentence generator, and this is going to conform to the generator type protocol. And I've got two properties here. One is the list of words that I have, and the second is the current index. So I'm going to start at 0 to start with the first word. And then, again, the implementation isn't that important, but I just have this single method that I need, and it's going to return the first word, and I'm going to increment the counter. And then the next time I'll give you the next word, and then the next word, and then in the else case here is where I've reached the end of the array, and I just return nil, and then that's how the iteration, the for loop will know that it should end. So once I have that extension in place, I can just call for word in sentence like this and print it out, and I'll get something like this, each word at a time. So again, I think value types are really important in Swift. It's something that we're going to be writing a lot of, and so I think it's important to keep in mind what are the things that value types do already in Swift, right? things like strings and arrays. We can compare them, we can check for equality, we can print them out and they look nice. They have hashing usually automatically, so we can put them as in a set. They have nice string conversion, and for things like arrays and dictionaries, you can iterate through them. So again, as you're building your own types, your own value types, especially in Swift, then you want your types to feel native as well, just like that sentence example. And again, the way to do that is with protocols in Swift. So I think protocols are really important, and again, I'm looking forward to the protocol-oriented programming talk to hear more about it. All right, let's move on to the last topic then, which is safety. I think when Swift was first announced, or if you've watched any of Chris Lattner's other talks throughout the WWDC sessions and elsewhere, then they always talk about how Swift was designed as sort of a safe by default language, right? If you've written a lot of C, then you know that, or C++, even worse, you know that there are many ways to mess things up, have a bad pointer, or go past the end of an array or something like that. Very, very easy to do in C. And so part of the reasoning behind Swift is to make that a little bit more difficult and to say, by default, we should try to be safe to keep things, keep the programmers safe and keep the code running more often. And I think a big part of keeping safety first is avoiding undefined behavior, right? Like in C, if you have a null pointer and you try to dereference it, well, that's not really undefined. You know it's going to crash, but the spec doesn't really say what it should do. And so in Swift, the idea is we always want to know what the code is going to do as much as possible. We don't want to say, I don't know what this is going to do at runtime. It could do this or it could do that, right? With Objective-C and dynamic dispatch, we had a lot of that. And so again, the shift with Swift is to say, no, let's avoid undefined behavior as much as possible. So a big way to do that is everybody's favorite feature, optionals, where again, before in Objective-C, it was you had all the objects were pointers, and then you weren't really sure. You didn't always have to check. Is it nil? Is it not nil? Because you could message nil, and your app would still be OK. Whereas in Swift, if you have an optional, you want to get the value. There's, of course, everybody's favorite force unwrap operator with the exclamation point, which if you talk to people about Swift style, people will say, this is OK, and then other people will say, no, you should never do this. You should always do it safely. So that's kind of a maybe still an open question. I'll give them a little bit. But there are a lot of ways to do it safely. You can do the optional chaining question mark. You can do the double question mark for nil coalescing. There's if-let binding. And then there's the new guard syntax that we got in Swift 2. Let's have a look. This is some code from the standard library, from the Swift source code. And it's something about Unicode and decoding some things. So again, the exact code isn't that important. But if you look at the first line in the function, let x equals input.next, that's returning an optional, right? So we're doing if-let to check the optional. If it has a value, then we're going to do fast path, I don't know what it does, check some bits, and if that is good, then we'll return a good value. And then the other stuff is, it's returning an error, returning empty. It's kind of not so clear. But there's a little bit more indentation in there to do a lot of checking. And if you look at this sort of the shape of the code, I'm just interested in the optional part, then there's an optional check first, and that's good, and then there's the second check, and then we can return the good value. So this is the code as it was about a year ago, and if you look at the source code for Unicode right now, then you'll see it's a little bit different. So that's the good case. Let me just show the bad case is that if the optional is nil, it actually goes all the way to the bottom, right? And it'll return empty value like this. So again, if you're concerned with optionals, then you have to sort of move your eyes, I think, a little bit too much, because the first case is up there, and then the bad case is down there at the bottom. All right, so let's look at the modern code. So if you look at the source code for Swift right now, this is what you'll find instead, and they've switched it over to use guard. So we've got guard, we're still checking input next, but then right away, if input next is nil, then you can just return right away. So it makes the optional part of it more clear, and it puts it right at the top. And it says if the optional is nil, then return empty input right away. There's our bad case, and then the good case is underneath that. Then we say, okay, now, sort of below this line, we have a value. So now let's do the check fast path, check the bits. If it's good, do this. If it's not good, then do that. So it really makes a clean divide, right? Above the line is we don't have an optional value, it's nil, and below the line is we do have a value, and we should do something with it. So again, I think this style makes it a little more clear, and it keeps that safety about optionals much more explicit. Let's move on to preconditions and assertions. Can I take another quick poll? How many people use preconditions or assertions in their code? Not too many, maybe 20 people or so. Lots of people in the front row, though. That's good to hear. Let's look at what the documentation says. Assertions are internal sanity checks that are active during testing, but do not impact performance of shipping code. So the idea is, while you're testing your app, you want to check some things, right? Is this value nil? Is there a value here? Did I get something back from the network? And so on. But once you do a release build, your app goes to the store, then the assertions are not checked anymore. So it's really stuff that you want to look at in testing. But if that case happens in production with your, when your users are using it, you don't want it to crash the app. But in development, you do want it to crash the app, stop at that line of code, and then you can debug it right away. So the other one is precondition, not so common. The documentation says this is a check to check a necessary condition for making forward progress. So that means we have to have this or we cannot continue at all. So precondition will, again, if you hit a precondition failure in your debug release, then the app will crash and you'll be in the debugger. But even in a release build, so if you put preconditions in your app that goes into the store and the precondition fails, then your release app will also crash and just stop right away. So generally they say this is more for library people. If you're writing a library or you're writing a framework, and the people who are using your framework are people out there on the internet that you don't know, and you can't really trust them, and you're not really sure what they'll do, then it's, they say, a good idea to have preconditions in your framework code. Let's have a look at some examples. There might be things like initialization failures, right? If you're out of memory or you couldn't allocate some resource, if you're like a networking library and you couldn't open the port, or you're some kind of data library and there's not enough memory, then you can't really do anything. And again, remember, the precondition means stopping forward progress. And you're just the library. You're not the final app. So you don't know really what the right thing to do is. So in those kind of cases, you can have a precondition failure to sort of signal that kind of problem. Another one that you'll see a lot is for, again, avoiding undefined behavior, right? If you're out of bounds or there's some kind of math overflow and what the correct behavior is isn't so correct in your library, then you could also use a precondition failure. So array, for example, arrays in Swift, if you go out of bounds, it gives you a crash. That's actually a precondition failure. And then there's my favorite, fatal error, which just always crashes the program, no matter what. All right, so let's have a look. So if you look in the Swift standard library, you'll see 180 calls to precondition. So again, this is sort of the Swift style. If you're writing a library or framework, you really need to check these kinds of things, then have preconditions, because that's what the Swift people do, so we should follow their lead. But if you look at how many assertions are in the standard library, it is 0. They have no assertions in there, because that's not the right thing to do, right? So just keep that in mind. If you're writing your app and you want to test something, have an assertion just for you in your debugger. But if you're running a framework or a library for other people, then think about using preconditions if that makes sense. So just to review, if you're in debug mode, all 3 of these will crash the app at the correct point: assert, precondition, and fatal error. All of them will do it. And if you're in release mode, then assertions go to sleep, but precondition and fatal error will still go ahead and crash the app. So again, keeping in mind safety, avoiding undefined behavior, and following the lead of what the Swift standard library people are doing, I think it's an important thing to have and to check for these unknown conditions in your own app, and especially in your own frameworks, because other people are going to be using your library and your frameworks. So that's part of Swift style. There are other things like the new error handling in Swift 2 with try and catch, and defer blocks, and things like that. But that's what I wanted to talk about for here. So we had value types, again, structs, enumerations, not as common, but use those enumerations. And again, seeing in the example of Swift standard library, where almost everything is a struct. So we've gone completely 180 degrees the other way, where we used to be all classes, and now we're all structs. So I think value types are really important to use when trying to write in like a Swift style. We saw protocols. There's so many things that are in protocols, like raw representable and equatable and all of those things. And so many of the features in Swift, like how enumerations work, how comparison works, how iteration works, like with for loops, all of that stuff is built into protocols. So if you want to take advantage of language features that Swift offers you, a lot of times using a protocol is the way to do it. And then there's, of course, safety. Again, Swift should be sort of safe by default is what we should all have in our minds. And there are a lot of ways that Swift offers us to be more safe, like the use of optionals, where, again, before in Objective-C, we weren't really concerned with the pointer values, and it wasn't always necessary to check. But now in Swift, it has to be explicit. You have to say, this can be nil, this can never be nil, and you have to have it right in the type now. And then again, the thing about preconditions assertions, checking your code, making sure you have tests, but also within your code itself, having the assertions and preconditions to check for those unexpected conditions. So here we are. I think Swift is still a relatively new language, and a lot of us are still figuring out how to write it. So I think the way to think about it is we're sort of at the beginning, this long hallway ahead of us, and the Swift wind is blowing in our face, and we're trying to go with it or try to go against it. I'm not sure. But I think as we keep writing Swift and we figure things out, and you guys continue to write and post something on your blogs and talk about it at conferences like this, then we'll kind of slowly figure out what we mean by Swift style as we keep working on it. And that's it. Thank you very much.
Okay, thanks, great. And my question is, when I when I enter my company, I found view controller have more than 4,000 codes. You know, that's the first time I saw that view controller. It's like give me a punch on my chest, and that's terrible and very hard to understand. After I hearing your sharing. Can you give me some advice to make the view controller shorter or make the code elegant?
Yeah, I think everybody has to deal with very large view controllers. I think there are a few techniques. Some people like switching over to MVVM, model view view model. So some talk about using that, but that usually just I shouldn't talk about it. That oftentimes will just shift code from your view controller to your view model. So it's just moving code around. And then you'll have a big view model instead of a view controller. But I think a lot of times the way to do it is to have small helper classes. Again, I really like Chris's demo because he had it split up into a short player class and a short game or player struct game class and so on. So that's one way to do it, is try to split up the functionality of your code. And sometimes you just can't get around it. You just need a class like a view controller that does 100 things. And then in that case, the kind of way to cheat is just to use extensions, right? And you could say, like we had categories in Objective-C, you have your main view controller that has all the properties you need and maybe the important view stuff. And then if you have some code that's specific to your app that does functionality to do with the gameplay, you can make a separate extension for that. And if you have code that has to do with handling the current state of the game, you could have a separate extension for that. So it's a little bit of a cheat, but it does help at least break up big blocks of code. So I found that to be helpful too. But otherwise, I don't think I have a general magic wand to say, here's how to do it, 4,000 lines down to 20 lines. I can't do that much. I can do 87 characters to 60 characters, but that's the best I can do probably.
I think the best way to learn the Swift guide is to read the source code. So do we have any suggestion for us beginner to divide into the source code, and where do we get started?
I think there are a few, the question was about learning Swift by reading source code. I think there's a few open source projects, so if you want to learn how to write apps, I can't think of any off the top of my head. I just learned about a Git client that's open source. I just learned about it today. I forget the name of it. GitUp? GitUp is a Git source control client. It's open source, so you can always look at that kind of code. There's also this Swift standard library, because Swift is open source now, so you can look at the Swift standard library, but the standard library is a little bit, has a lot of tricky code, as our previous speaker would maybe say. So that's maybe not the best place to look. But if you're curious about like how does a string work, or how does an array work, or how does a dictionary work, or how does an optional work, then it's nice that now we can go to the Swift source code. So if you want to look in there and kind of look at how they do things, I think that's I do that a lot. It's just kind of fun for me to look at because we use dictionaries every day and we know them very well. But if you get to open the box and see what's inside, so if you want to read through Swift source code, that's also, I find, a lot of fun if you want to try that.
My question is, there are many discussions on the internet whether we should use keyboard guard or not. I want to know which one do you prefer or recommend? Thank you.
I'm sorry, I didn't hear whether we should use keyboard?
Guard, keyword, guard.
Guard.
Yeah.
Got it, okay. I think the thing about guard is if you have a guard, you want to check some condition, else you have to exit. You have to do return, you have to, well, return or continue inside the loop, or you have to do, again, my favorite, fatal error inside the guard. So if there's no value in the optional, I want to do all of this 10 things, and I want to keep going, then you can't use guard. Because with guard, you can't keep going. You have to stop at the end of the guard. You have to return or something like that. So that's one case where you can't, or you can't really use guard. But otherwise, usually, I think in most cases, it's I have an optional. If the optional has a value, I want to do all of these 100 things. But if there's no value, I just want to skip it. That's the usual case. So I think most of the time it's okay to use guard because you just say, if there's no value, then just return or continue next time through the loop or something like that. So that's just the way guard is built. It has to exit. So that's really the answer to the question. If it's okay to exit, then I would say always use guard because the condition is flipped, right? You're not saying, is it empty? You're saying, no, I want it to have a value, else return or fatal error or whatever. So I think it reads a little bit nicer. So but that would be the answer is, if it's okay to return, then I would use guard.
Hi, Greg. You just said that a good programmer can make code easy to understand. But maybe for me, a good programmer can make the error easy to be seen. Mm-hmm. And you just said that the preconditional check and assertion, I think, is a kind of method to discover the error. And have you any other suggestions to make error easy, make error clear?
I think those are definitely the big ones, right? If you have an assertion right in your code and it says x equals 7 or something like that, then that means it has to be 7, so it reads very nicely, right? I think that's really the strategy to have. There's always documentation, I guess. Again, if you're writing a framework, then sometimes the people can't see your source code. So if you have a precondition and it just crashes, then they might not know why that is. So I think that's also an important thing, is to have good documentation, comments, whatever, so people using your library will know what you're talking about and what the conditions are. But I think otherwise that's really what I would say to do, because assertions are code. Like the problem with comments that everybody always says is comments can go out of date. If you write a comment, you change the code, you don't change the comment, and then it just sits there forever and it's wrong. But I think that's the benefit of preconditions and assertions, is that it's going to run them every single time. So if they're wrong, you'll know right away. And if you change the condition someday, then that changes right away too. So I'm not sure I have any other good strategies, but I like those two because they're code and they run and they're sort of always up to date. So I think that's just the way to go.
I wanted to know how your Swift style changed over the year and a half.
How did my Swift style change over the year and a half? I started using guard more. And it was funny because when I first started writing Swift, I was converting a lot of projects. So I had Objective-C, I took out the square brackets, and instead of a space, I put a period for method calls, and that was it. I had Swift, and I was done. But now I find I'm doing it the other way around. When I write Objective-C, I always check for nil, and I always check the conditions before, and then my Objective-C is very, very long because I'm always checking for all these cases that are okay. So I think that's the biggest way that my Swift has changed over the past year and a half. Is it's definitely gotten shorter, and I'm more careful about checking conditions, and especially checking for nil compared to Objective-C. That's probably the biggest thing. And overall, it's gotten shorter, which is nice. Less code, which I know you like. So.